if everybody can hear me, we're going to go ahead and get started. This topic is going to be on XMP and how we can make metadata connect with our documents. My name is Schnarr. I'm with ActivePDF, one of the sponsors, and I was asked to give this talk about some of the, how you use XMP and some of the exciting possibilities that it opens up for us. So, what is metadata exactly? Well, using the definition from the XMP spec, metadata is data that describes the characteristics or properties of a document. It can be distinguished from the main contents of a document. Now, that last part is especially important, being able to distinguish metadata from the contents of a document. Take, for example, a book. You can use metadata to describe about the book, the author, published date, subjects, things like that, without having to actually read it, or in most cases even be able to understand. It could be in a different language. It could be a text spec about a subject that you have no former knowledge to build off of, but you can still use that metadata to build information about the book. Now, put it another way, metadata allows us to give context to our documents or our resources. So we can use context to solve the mystery of the dead cat. Now, this is a reference to a favorite HBO miniseries of mine, Earth to the Moon. And this guy is trying to teach these astronauts about geology and how to use context to know what is a good find and what isn't. And so he posited that context was mystery of the dead cat. If you bring him a dead cat, all he can tell you is that it's dead and it's a cat. If you bring him a dead cat and tell him you found it on the road, he can guess that maybe it was heat exhaustion or hit by car. If you bring him a dead cat and tell him you found it in your favorite kitchen of your favorite restaurant, then it may very well have been killed by the chef. And so he ended with context is the difference between roadkill and a meal. And so for us, we can use that context to allow people to know more about our documents. If we get a PDF emailed to us as an attachment, the best we can do is just open up that PDF, and we have to dig into it to find out what that resource is for, what it's about, what it relates to. But if we could use the metadata without even having to open up the document, we could know what it's for, what we're supposed to do with it, and be able to process it a lot faster. So XMP, Extensible Metadata Platform, is what we use to provide a common standard for multiple applications to work with our metadata. We use XMP because it provides a data model and a storage model that uses XML. So if you were worried about not seeing any XML today, don't worry. We've got quite a few examples that use XML heavily for that. Then once we've serialized it to XML, we package these the serialized XML into our resources, in this case, for today's talk, PDF. And then finally, XMP offers schemas. Those schemas can be used to build off of what other people have done, or we can extend existing schemas, or in some cases, customize and create our own. All right, a little bit about me. I'm technical manager at ActivePDF. I've been there for going on 10 years. Recently, metadata is something that's become one of our goals for several of our products, and so this is something that we've been interested in for the last couple years, heavily interested in the last couple months, and so it was one of the talks we wanted to give here, and then I was asked to present it. Takeaways from today's talk. I want everybody to be able to have a better understanding of XMP, the data model, the serialization, and extending with custom schemas or extending existing schemas. And then in addition to that, how does XMP relate to your PDF? How do we use it with our PDFs? And then some sample scenarios using that metadata in our PDFs. So XMP's been around since about 2004. The data model for it is pretty basic. What we do is we have resources. These could be documents, it could be portions of documents. For example, an image inside of a PDF could have its own XMP metadata compared with the whole document having its own XMP metadata. Resources have properties that describe the metadata. Those properties each have a name and a value. So if we look at this example here, the property name would be, for example, creator. The resource would be Star Wars, and the property value would be George Lucas. If we use the release date, you will get the same thing. Property name is released, property value, May 25th, 1977. And so that allows us to describe almost anything you can think of and write out as metadata. Now, a little bit about property names. Because they are going to be serialized to XML, they need to be legal XML qualified names. What does that mean? It means they have to be in a namespace and they have to be well formed. So if we look at the top example, that is a valid XMP property name because it exists in a namespace designated by that XMP prefix, and it's a well-formed name. The next example down is well-formed, but it doesn't have that namespace prefix, so it's not a valid XMP property name. The third one is in a namespace, but it's not well-formed because that second A in the date is uppercase and XML is case sensitive, so this would not be a well-formed XMP property name. A little bit more about schemas. Those are where we define those namespaces that we're using with those prefix. And you notice I use the prefix a lot, and that's because prefix is highly recommended. It's going to make your XMP documents a lot more readable for just clients opening up and reading it as plain text. You'll want that readability, and otherwise you just have long strings with every single property that exists in your document. A couple of rules about XMP namespaces. They have to end with a / or a £. These are to clearly delineate where the namespace stops. This allows some prevents overrun if you have a namespace that's, for example, my namespace, and then I have some property called prop1. And then oddly enough, somebody out there in the world has a namespace called my namespace prop1. A consumer is not going to be able to differentiate between those two unless you have something that delineates namespace from property. And so that's why XMP uses that / and that £. So if a namespace doesn't have either of those, it's not going to be valid, as you can see with our very last one on that bottom example there. Property values. These can be three basic categories. The first one is going to be simple types, just whatever you think of: standard, Boolean, integer, string. Also choice, which is just a collection of strings that you get to pick from. You can also use those simple types to create structures. If you're familiar with object-oriented programming, think of these as your objects. So this allows you to get a little bit more customization going to describe complex objects using metadata properties. Now, there is one final way, and that is arrays. Collection of values. These can be arrays of arrays or arrays of structures. Just essentially what it is, just collection of values. There's three kinds that we're going to look at for XMP. The first one is unordered, and that is exactly what it says in the name. The order has no importance at all. So the typical one for this is going to be keyword or subject. It's not really important to the client to know PDF is a keyword before XML if we were doing a resource for today. But the order could be in any order, XML or PDF. However, if the order is important, we do that second type of array, which is ordered, and you'll see that showing up in your XMP as sequence or SEQ. And that one just says the order of how these items are in the array is important, and they should be taken as such. The final one is alternative, and this presents the application or consuming reader with options to choose from. The first one in an alternative array is considered the default value. And we'll have a couple more examples of these in the next slide. One final thing I want to talk about is that XMP allows you to qualify properties. So if we go back to that example of George Lucas creating Star Wars, we can, let's say, well, we've got lots of people who worked on Star Wars. Now we can qualify by saying he worked on Star Wars as a director, or somebody else worked on Star Wars as a producer. And so we can still take that simple type, but just wrap it with an additional qualifier to explain a little bit more context about what they did or what that property value means to the resource that we're talking about. The most commonly used property qualifiers are language alternative arrays, and we'll see that in the next slide here. First thing I want you to notice is that this is DC title. That's going to be the Dublin Core title. And Dublin Core is used to describe and document multiple resources, and so you'll see a lot of that namespace in your XMP, especially in the XMP that's set using a standard reader today. Alt is that alternative array, so this is providing the client with a choice of, in this case, titles. The first one is the default. in English. Second one is English, French, and then Italian. So the application could pick which one, based on that language qualifier, is the correct title to use. All right, now that we have a little bit better understanding about the data model, let's talk about the syntax that we're going to use to serialize and store our XMP in XML. XMP is serialized using the Resource Description Framework standard, which is a subset of XML. RDF is an open W3C standard. If you have any question or interest in that, it's fully documented on the W3C site. All XMP associated with a single resource should be stored in a single packet. Now, I'll spend a little bit more time talking about that because it is important. All metadata with a resource should be in the single packet. That means you should not have multiple packets describing the same resource, nor should you have one packet describing multiple resources. Every resource should have its own packet. That way, if you can separate resources as needed, but they still get fully described with their attached metadata. XMP structure with XML. The outermost XML element of a serialized XMP is going to be X, which is the preferred prefix for Adobe's namespace for Meta, with that, again, that /. XMP Meta is the name of the element. Older versions of this use XAP Meta. Both are still valid. So if you're going to be consuming XMP, you should be able to look and read both of those elements. If you're writing XMP, then you want to use the newer one, the XMP Meta. What does it look like in, when we tag it? It's just simple XML. We've got the element. We have that attribute that we use to describe the prefix that we're going to use. And then we have our serialized XMP inside. Now, XMP Meta does not have any, this is a typo on my part, and I apologize, required attributes. There are optional attributes that are out there, but there are no required attributes that you need to use for XMP Meta. Inside, you're going to have at least one element of RDF. And the RDF prefix is Resource Description Framework prefix at that URL there. And again, notice the pound sign at the end. RDF element, we have the RDF prefix described. Inside, we are going to have at least one description element. That description element is where all of your XMP properties are going to show up. All right, now, inside that description, I want you to focus on that RDF about. This is a required attribute for every description element in your RDF overall element. The about attribute allows you to describe information about the resource that is being documented. Most often, it's just going to be left blank. But it does give you an option if you want to describe it in addition. But it is a required attribute. Additionally, if you have multiple description elements, that attribute has to be the same across all of the description elements in your RDF packet. And why would we want multiple description elements? Because if you have multiple namespaces, it makes it a lot more readable to break them up into their own description elements. So you have one description element per namespace. That way somebody coming in looking exactly for your namespace doesn't have to go through a long list of properties. They just go through the elements until they find the one that describes their namespace, and they can pull the property straight from there. Now that we've got the outer layers defined, let's talk about how we serialize the XMP properties. Simple types are going to be written just as elements of RDF description. And you can see there we've got DC format, which is another Dublin core. This just documents the format of the resource, in this case application/PDF. It's got our opening tag and our closing tag, and if you don't close it properly, it's not going to be valid, you'll break it, world ends, all that fun stuff. But we also have a shorthand where we can use simple types as attributes of the RDF description. And so that's what that second example is showing. We do DC format as an attribute and specify the same value. Which you use is entirely up to you. They're both valid. I personally find that using them as XML elements makes it a lot more readable when you're looking at it as plain text. But the attribute approach makes it a lot more concise and a little bit shorter. Structures, when you document those, you are going to have either an RDF description element wrapped around them to identify it as a complex structure, or you're going to use RDF parse type equals resource to flag it as a shorthand version that says this is a structure, but you don't have to have that inner description. So example of that can be seen here. The top uses the inner RDF description element. So you can see we've got our outer description, we have person, we put our inner description element that flags this as a structure, and then we have our values, name and hometown. At the bottom, we're using the shorthand version. And so that gives us RDF parse type and equals resource. Same names and values. The only difference is we don't need that inner RDF description element anymore. Arrays. These are going to be pretty much the same across all of the array types. Unordered, also known as bag, is going to just show up as RDF bag, and then inside you have RDF li, which is list item, and you just list the values in there. Sequential, the only difference between sequential and unordered is going to be RDF bag. You're going to replace it with RDF seq for sequential. Same thing for alternative, just RDF alt instead of RDF bag. Now a couple examples of those two types of arrays are on the next slide, so let's take a look at those. Property qualifiers we talked about. When we serialize those, they have an inner RDF description, and they use RDF value. The final one allows us to specify that qualifier. In this case, we're using a made-up namespace, my namespace, and we're saying role. And so this allows us to specify George Lucas's role in this resource as director. And then this is inside of a list item, which is inside of a sequential array. The DC creator is a sequential order, so you can give preference to the creators that we use, whether it's alphabetical or importance or whatever you ascribe, but it is going to be a sequential array. So moving on, the next one is going back to that language example we showed before, specifying different titles based on the languages that you have available. This is how it would show up in your XMP XML. You'd have RDF alt, you'd have your list items, then we use that XML language attribute to describe either it's the default or it's the English, language, French, Italian, and then we specify the values. All right, so we've talked about how to serialize the XMP. Let's talk about how to make it into a packet that we can include with our resource. XMP packets are made up of 4 parts. The first is the header. This is composed of a XML processing statement, X packet. This has 2 required attributes. The first one is begin. This value is going to be the Unicode 0-width non-breaking space character. Now, good news for that incredibly long statement is this tells us what encoding was used to write the XMP packet. PDF requires any XMP embedded be UTF-8, and there is backwards compatibility. UTF-8 can be described with begin using an empty string. So a lot of the PDFs that you see with XMP metadata right now will have that empty string instead of the zero Unicode character. But that is where you would specify it so that the reader can see what encoding was used to create that packet. But anything that goes into PDF has to be that UTF-8, whether you use the correct space or you fall back to the backwards compatibility empty string. The next one, which has to be separated by exactly 1 space, is ID. This lets you specify what version of the XMP reference was used to create your packet. Anything that was created since 2005 is going to be using that ID you see up there, W5M, 0M, and then all the other characters. That uniquely identifies the version of the spec that was used when you created your packet. Next up, after our header, we have that XMP data. Beneath that, we have padding and we have trailer, and I'm going to talk about those together. Padding and trailer are going to be used pretty much exclusively by consumers who do not understand the host format. In our case, PDF. If a consumer comes in that doesn't understand PDF format and so is not going to be able to update or write PDF, we need to give them a way to make changes to our metadata without breaking our structured PDF. If they come in, make changes that makes the metadata longer, and they don't update the cross-reference table, anything that happens after that metadata is going to be invalid. It won't be found using the original cross-reference data. So instead what we do is we use padding. In this case, it's going to be 2 to 4 kilobytes of white space. And you're going to want a carriage return about every 100 spaces. That way applications can come in and use that white space to make changes in the document to your metadata. If, however, you do know PDF, and so your application is going to rewrite it anyways, then it's not as important. You can change the XMP metadata, rewrite the PDF, rewrite that cross-reference information, and then the PDF will still be valid and work. The trailer allows you to specify if your data is even writable in the first place. So that's where that W comes in. If you want clients to be able to write, you just use W. If you do not want them to touch it, you would use R. And then here's just a full example of what a packet would look like. We have our header. We've got the Serialized XMP. We have a rather shortened version of the padding. And then at the bottom, we're saying that non-understanding clients can make changes to this using the padding. All right, so moving on to custom schemas, ways to extend XMP to make it work for your specific needs. First one is creating our own schema. If we're going to do that, we need to make sure that we avoid using properties that exist syntactically in other namespaces. So if somebody else already has a published namespace that has the same property name and type, you'll want to use theirs, because otherwise you get fragmentation and just a lot of confusion coming in. If you're going to create a property that you think might be used by multiple people for multiple different reasons, then look into creating a common namespace that can be shared among anybody who's interested. Now, aside from those caveats, all we need to do when we're going to create our own is create a human-readable spec document that outlines our namespace. That way we can deliver that to any developers who would want to use our namespace in their own metadata. What does that spec have? We have a unique name, we have a URI, we specify a preferred prefix, and then we have a table that outlines the names and values and types. In addition to creating our own schema, we can extend existing schemas. Now, so we can add properties to existing schemas. We are not allowed to change properties because once it's published, you consider it written in stone, because if somebody else is using that property and we change it, then we've just broken their XMP metadata. So extending works, just make sure you don't change anything that's already in existence. Here's an example of a couple properties from the Dublin core schema. So they have a name, they have their URI, and then they have preferred prefix, and then underneath that they have the first couple properties from their schema. So we have property, we have value type, category, and then description. Most of those are pretty self-explanatory. Category is used to delineate between something that the application that's reading the PDF would set, like internally, like say date modified. That's not something that typically the client is going to set in the metadata for a file. But if it's external, that means this is data that's going to be set by an external force. So for example, title is something that's set by either the client or the client application. Example of creating our own schema, we call it orders. We use namespace, end it with that slash, and then we have our preferred prefix, which is SO. Underneath that, we have property, type, and description. Since this is custom, unless I'm creating a custom application that's going to set some of these internally, almost all of your properties from custom schemas are going to be external. All right, so we've got our XMP packet. Now we need to embed it into our PDF. How do we do that? As of 1.4, you were allowed to embed it using metadata objects. So those are stream objects, and you can embed those into the PDF. These are referenced using the metadata flag that is used with either the document dictionary, or you can actually apply metadata to individual objects in your PDF. As I said before, these have to be UTF-8 encoded. So you're going to be able to get away with using that empty string for your begin value. Inside, what it looks like, we have two new types that we need to set. Type has to be metadata, and then subtype has to be XML, because that identifies it as XMP XML. And then aside from that, standard stream dictionary entries there. We have our stream keyword, XMP data would go inside, and then we close up the object. One final note about embedding XMP into your PDFs is we do have the option to separate our metadata when it comes to document encryption. The default is when you encrypt your PDF, your metadata is encrypted. However, there is a flag that we can use to set that to false, and so when we encrypt our PDF, our metadata is not encrypted. Why would we want to do that? Because it would allow people to understand context about our resource, in this case our PDF, without having access to the inside content of it. So keywords, search terms, whatever we want to have in our metadata that they can use to properly index and access just a list of files, we could do using unencrypted metadata. If your metadata has something that's sensitive, obviously you would want to encrypt it with your document. All right, so next up, let's talk about a couple examples of how we can use metadata to make, what my boss likes to call intelligent PDF. First example, document name. We get a document, we convert it to PDF, and then we archive that original document. We write the original name of the document into our XMP, and then our PDF enters a workflow where it could get altered, renamed, all of the above. And at any point in that workflow, we can come back to that metadata and find the original file that was used to create this document, allowing us to reconnect the PDF with our original document. Another one, email archiving. We want to archive emails that come in. What we do is we convert the emails to PDF, encrypting so that we can prevent people from accessing, but we do not encrypt the metadata. We add the standard from to, date sent, date received, CC, BCC, and subject to our metadata in our PDF. Then we can do searches based strictly on the metadata without having access to the PDFs to find any document related to a particular sender or receiver or subject or date range. And again, all without having the passwords to even access those PDFs in the first place. Example of a packet that would describe that. We have it inside of our RDF description, all the correct tags. We're using multiple description elements because we're using multiple namespaces. And then the second description element near the bottom there is being used to describe my email namespace. I've got from, to, and then subject. And using that metadata, I could access this PDF and know that it contained information about either related to any email that I sent, any email that John Smith received, or if we're going for a completely nerdy search, any email that references Star Wars or Star Trek. Another example is physical invoices. We get a purchase order that comes in. At the time that we have it, we have all the information we need as it's right there and fresh. So what we can do is scan that to PDF, store the invoice number, total amount, customer ID, parts, anything we want to store for later as XMP metadata, and then we can archive the PDF. Encrypt the PDF if you want. At any point, we can come back to that metadata, search it by invoice number, or search for all orders that were made by a customer ID, and we can find it using that metadata and reconnect it with our CRM or our ERP. All right, so you can apply this even to a digital invoice. So let's say a PDF comes in. At the time we get it, we extract text from the PDF to be able to get the order number, all this information here, and automatically add it to the XMP metadata, and then send the PDF to be archived. So multiple ways of getting the data we want metadata for, whether it's manual or automated using PDF tools. Another one that's really got a lot of potential is workflow status. Here we've got a simple workflow. Client gives us a PDF. We update the XMP with submitted. Then we send the PDF off to be validated for the form data. Then we go to XMP gets updated with validated. Then we send it off for approval signature. Now, at any point, we can get a file dropped in that's been disconnected. Maybe it's sat on somebody's desktop for a couple weeks and they just found it, and so they sent it off to whoever their contact is. Without that metadata, we would have no idea what this file is for. We would have to open it up and dig into it to find out what this file is for, what the context is, what do we do with this document. But if we have that state saved, and this is very simple, just one flag, we know what the next state is that this has to go to for workflow. If it doesn't have that state, that means it hasn't entered the workflow at all. We can just send it right to the start. So that allows us to easily connect any document that's been separated from our existing workflow back into the next state for processing. Another one is loan package. Anybody who's ever done a house mortgage or loan or purchase knows there's a lot of paperwork associated with getting a loan. What we do, example, would be set a loan ID, required parts using a bag text, and then optional parts using a bag text. Now, loan ID would store the ID of the loan itself. The required would be any file that's required information. And then the optional would be any file that is optional. You don't need it. It's secondary to the loan information itself. With this information in place, we could use any file in this package to rebuild that loan package. Every file is able to re-identify any other required document or any optional document. And so we can get sort of a peer networking of our files to identify each other so we can package everything up and grab exactly what we need. A couple other options. I mentioned e-commerce. You could generate your invoice and store information such as the IP address of the purchaser. You could store that as metadata. If you're, another one would be city planner. You have the permit number, you have the building address in the metadata, and so we could use that to index any file associated with a permit request for a specific address or with a specific number. Students, want to archive student transcripts. You store the student ID in the metadata, and again, encrypt the PDF if you want to prevent this, protect the student information. We can still find all the PDFs associated with this particular student based on that metadata search. And a couple final comments. First and foremost is use metadata. The more people who use and create metadata is going to create more demand for people to read and use existing metadata. If you want people to tap into your workflow, metadata is an excellent way to do that. And if you're going to write metadata, write it to XMP. You'll notice that PDFs have the document dictionary, the info, where you set your standard title, subject, keywords, all those. But if you write it to XMP, XMP will take precedent in most common readers. So if you're going to write it to the XMP or write it to both, but don't just write it to the document info because it could get outdated at some point. And then final note about this is that PDFA does require XMP metadata. So if you're already using PDFA, you already have access to existing XMP, just add in your own schemas. And then just in summary, just here a couple references I used. XMP spec is essential for understanding the overall syntax you're going to use for serializing it. I use the one from the Adobe site, but as it's now ISO, you can also get the version from there. PDF reference 1.7 is if you have any questions about embedding metadata into your files, this is where you're going to find it described with that metadata stream. And then Leonard's book, Developing with PDF, just kind of helped put that into user-friendly terms for me. Any questions? Yes?
Where did you say the XMP goes?
It's going to go inside of a metadata stream object, and so that can go anywhere. With random access offered by the cross-reference, it can go anywhere inside. You just need to flag it as a metadata stream.
Okay, so it doesn't have to be part of the catalog.
No.
Stick it in.
Yeah, you stick it in, and then if you're wanting it for the document, you would put it in the document dictionary, the metadata object, and then point it to that metadata stream. Any other questions? Yeah.
Is there, I don't know if that's a good question, is there any relationship between TAG PDF and everything we talked about? I mean, it seems to me both are talking about the structure of the document and exposing it in some way.
TAG PDF is definitely talking about the structure of the document, and as far as layout and accessibility, XMP is going to be talking about the context of the document. So they could both be used in conjunction with each other to fully describe not just how the document flows, but also how the document relates to everything outside. So they're not, I would say they're side by side. They're not going to be one or the other.
But they're not coordinated in any way.
No. Yeah?
Are you aware of any cases where the XMP
QR code or barcode which would in terms of textual properties?
XMP is designed to be super extensible. There is no validation aside from just basic XML. So whatever you could put into an XML document, you can put into your XMP. So that could easily be, a binary dump of a QR code or a barcode that you would just read out into your custom application and then have access. So it's not in the PDF, but it's in the metadata. So anything that you can textually represent in XML can be represented in your XMP. Other questions? Yeah.
PDF specs says you can have metadata that's associated with images or other content. I'm not sure I've ever seen that used in practice. Do you see it?
Metadata is not something that we currently see a lot of. We're definitely wanting to encourage people to do more of it, but because you are correct, you can associate it with images inside PDF. So a practical use with that would be you get an image that comes in and it has its existing metadata from when it was created, how it was created, what tools were used, and you store that as metadata stream, and then you point that X object to use that metadata. And so that way you have that metadata for the entire time that it exists in that PDF, and if you were ever to extract that image, you could get the metadata associated with it so that you're preserving it for any future use down the line. Any other questions? All right, I think that's it. Thank you very much.